Hello everyone, I'm Samarjeet Singh Kheda from Acropolis Institute of Technology and Research, and I would like to welcome you all to my presentation on AWS Fargate. Today we will explore how Fargate simplifies running containerized application on Amazon Web Services. By the end of this presentation, we would have discussed the core concepts of Fargate, its advantages and how it integrates with other AWS services. So here are the topics that we are gonna discuss throughout this whole video. Now first of all, moving on to the question, what are containers? Well, containers are self-contained units of software that package not only our application code but its runtime environment, all the required system tools, settings and other dependencies. Think of them like tiny shipping containers of your application. Each container runs in isolation from other containers even if they are on the same system. This ensures efficient resource utilization and consistent behavior. Popular containerization technologies include Docker and Kubernetes, which we will discuss in much detail later. Traditionally, deploying containerized application involves provisioning and managing servers, typically Amazon EC2 in case of Amazon Cloud. This approach requires manual scaling of the infrastructure based on traffic demands. Additionally, you would be responsible for patching and updating the underlying OS of these servers. Along with configuration and managing security aspects, this can be a real time consuming and complex task. Here's where AWS Fargate comes in. Fargate is a serverless compute engine specifically designed for running containers on AWS. With Fargate, you no longer need to provision and manage servers yourself. Instead, you simply define the resource requirements for your containers, and Fargate takes care of everything behind the scenes. Fargate automatically scales your containerized application based on their resource needs, ensuring optimal performance. Plus, you only pay for compute resources your containers actually use, leading to cost optimization and less cost. Now, there are several benefits of using AWS Fargate. Here, I have only listed a few of them. First, it significantly simplifies container management by eliminating the need for server provisioning and maintenance by ourselves. Fargate also automates scaling and ensuring your application have the resources they need to perform optimally. This allows you, the developer, to focus on building and deploying your application without getting bogged down by the complex infrastructure management. Additionally, the pay-per-use model ensures you only pay for the resources your containers consume. Finally, leveraging AWS secure infrastructure provides an extra layer of security for your containerized application. One AWS service that integrates seamlessly with Fargate is Amazon ECS, or also known betterly as the Elastic Container Service. ECS provides a way to orchestrate and manage your containers on AWS. When using Fargate with ECS, you can choose Fargate as the launch type for your ECS task. This essentially tells ECS to use Fargate to provision and manage the underlying compute infrastructure needed to run your containerized application. ECS takes care of container placement on available compute resources and manages the lifecycle of the containers, which includes start, stop, and restart. Your role is to define the resource requirement for the container and configure launch specifications with ECS. This way, you can leverage the orchestration capabilities of ECS while Fargate handles the serverless aspect. Another AWS service that integrates with Fargate is Amazon EKS, the Elastic Kubernetes Service. EKS is a managed Kubernetes service that simplifies deploying and managing containerized application using Kubernetes. By using Fargate as the compute engine for your EKS clusters, you leverage the power of Kubernetes for container orchestration while Fargate handles the underlying server infrastructure. This frees you to focus on managing your Kubernetes deployment and application logic. AWS Fargate offers a wide variety of use cases due to its flexibility and scalability. Here are some common scenarios where Fargate could be beneficial. First of all, microservices architecture. Fargate is ideal for deploying microservices, which are small independent services that work together to build a larger application. Each microservice can be packaged as a container and run on Fargate, ensuring efficient resource utilization and fault isolation. Now, the second use case could be a batch processing task. Fargate can be used to run batch processing jobs that need to scale up and down based on workload. You can define your job requirements and Fargate will provision the resource needed to complete the job efficiently. Now moving on to event-driven applications. Fargate is well suited for event-driven applications that react to external events. When an event of your application is triggered, Fargate can automatically scale container instance to handle the processing load. Now moving to our last use case, serverless application. When combined with AWS Lambda, Fargate can be used to build serverless applications. Lambda can handle short-lived tasks while Fargate can manage longer-running containerized workloads. Now, in conclusion, AWS Fargate is a powerful and convenient service for running containerized application on AWS. It eliminates the need for server provisioning and management, automates scaling, and offer a pay-per-use model for cost optimization. Additionally, Fargate integrates with ECS and EKS, providing flexibility for container orchestration needs. By leveraging Fargate, you can focus on deploying and developing of your application, leveraging the infrastructure management of AWS. Now that's all from my side. Thank you for watching. Have a nice day.